We're going to start with trig functions in chapter 5, the unit circle approach. This is a chapter where you're going to have to do a lot of beginning memorization to learn. If you do not already know the unit circle, that's something that you're going to have to spend some time with. But once you know it, like riding a bike, you can use it in a lot of different places. So we'll look at the unit circle and terminal points on the unit circle and what is called reference number. In this section, we'll explore some of the properties of the circle of a radius 1 centered at the origin. That is why it's called the unit circle, because 1 is 1 unit of measurement. So here's a unit circle with a radius of 1, and the equation for that is x squared plus y squared equals 1 right here. Right here's your formula for a circle with a radius of 1. And they're just repeating it here. Now, we're going to show that point P, which is the square root of 3 over 3, and the y value is the square root of 6 over 3, is on the unit circle. So how we would do that is first we would remember that we have this value being our x value, and this value being our y value. So in order to see if it is on the unit circle, you're going to square your x value plus your y value, and then you should get 1. So I square the square root of 3 over 3 plus the square root of 6 over 3 squared, and I have 3/9 plus 6/9, which will give me 9/9. And 9/9 is equal to 1. So it is, in fact, on the unit circle since it makes a true statement with the equation of a unit circle. Now we're going to take a look at points that are called terminal points on the unit circle. Here we are starting at 1 on the x-axis, and we are going counterclockwise in this direction, and we stop at some point, and that point is then called x comma y. Now I did not have to stop right here, but I'm just going randomly and stopping in a place and showing you that if you go in the counterclockwise direction, that's what it will be. Now, this is happening when t is greater than 0, which means you're going in a positive direction. Now, if t is less than 0, you start here and then you go what we would call clockwise, and we would get our point x comma y. So in this way, we arrive at a point, again, x comma y on the unit circle, and the point x comma y obtained in this way is going to be called a terminal point. So when we started that place on the x-axis where we are at 1, and we travel either clockwise or counterclockwise, we will get a terminal point. The circumference of the circle is 2 pi r, as we know from our formulas in geometry. Circumference of a circle is 2 pi r. And r in this case is 1. So that's how we get our 2 pi. So if we start at 1, 0, and we move counterclockwise all the way around the unit circle to return to 1, 0, it will travel the distance of 2 pi, which is in fact our circumference. Now, if we go halfway around the circle, it will travel the distance of 1/2 times 2 pi, which is pi. If we go a quarter of the distance, it would be pi over 2, and so on. Where does the point end up when it travels these distances along the circle? Figure 3 will show. We see, for example, when it travels a distance of pi starting at 1, 0, the terminal point is 1, 0. So again, here I'm starting and I'm going only pi over 2, and I am at 0, 1. Here I will travel pi, and I will be at -1, 0. Here I will travel, sorry about my messy curve, 3 pi over 2, which is 270 degrees, and that will be 0, -1. And if I travel 2 pi, meaning I will go all the way around, I will be again at 1, 0. So now we want to find the terminal point on the unit circle determined by the real number t. Here we have 3 pi, we have -pi, and we have -pi over 2. So let's take a look. 3 pi means I will go all the way around the circle once. That will be 2 pi, and then I'm going to go 180 degrees more, and that would end up here giving me -1, 0. B says I will go -pi, which means I will go backwards or clockwise, and I will end up -1, 0. And C, I'm going to go clockwise again, or backwards as we would look at it, and we would go travel -pi over 2 and get 0, -1. Now, while I'm at this last one, how else would I get 0, -1? Well, I would get 0, -1 if t were equal to 3 pi over 2, which is 270 degrees. It would also give me 0, -1. But in that case, I would be starting here and traveling counterclockwise all the way around to here. So there are several ways that you can get the same terminal points. Again, terminal point determined by 3 pi is -1, 0. Terminal point by -pi is -1, 0. And the terminal point of -pi over 2 is 0, -1. And different values of t can determine the same terminal points because we're going in a circle. So the terminal point that is x comma y determined by pi over 4 means you would start here and you would travel pi over 4 distance. And we would have the square root of 2 over 2. And my y value also would be the square root of 2 over 2. So since the unit circle is symmetric with respect to y equals x, it follows that P will lie on y equals x. So P is the point of intersection in the first quadrant of where we have y squared plus x squared equaling 1, and the line y equals x, which is our parent function. So if I substitute in x for y in the equation, I get x squared plus x squared equals 1. And I'm going to continue to solve. I get 2x squared equals 1 by combining like terms, then divide by 2 and take the square root of both sides, and that's how I will get the square root of 2 over 2. Of course, I'm going to rationalize this by multiplying by the square root of 2 over the square root of 2, because I don't want to leave that denominator on the bottom. And again, that's how I will get the square root of 2 over 2 and the square root of 2 over 2 for my y value as well. They just happen to be the same. And you should also recognize that that is when it's at a 45-degree angle when you're taking a look at radians to degrees. Hopefully you caught that. So similar methods can be used to find the terminal points of pi over 6, pi over 4, pi over 3. Now there are certain points that are used more common than others, and these are the points that you're going to see in these tables. And yes, that means that these points are important. And that would in fact mean that these are the points that I'm going to give you a quiz on. So you need to take a look at when it's 0, my terminal point will be 1, 0. When it's pi over 6, it'll be square root of 3 over 2, comma 1/2. Pi over 4 is square root of 2 over 2 and square root of 2 over 2. Pi over 3, 1/2 and square root of 3 over 2, and pi over 2 is 0 and 1. So finding the terminal point determined by each given number t. Now here I have negative pi over 4, so I have to remember that I'm going to start at that 1, 0 point and I'm going to go backwards pi over 4. And then I have 3 pi over 4 for my t for b, so I'm going to go in a counterclockwise direction. And then in c, negative 5 pi over 6, I'm going in a clockwise direction. So if I let P be the terminal point determined by negative pi over 4, and Q be the terminal point determined by pi over 4. Right here, again, I'm going to go up my 45 degrees. Here's my y equals x going through the circle that we talked about earlier. Sorry, my drawing isn't as neat. Ooh, that's really bad. Let me erase that and make it a little bit better. I'm going to go right through. Let's hope I make it better. There we go, right through there. All right, and now if I go backwards, I'm going to be at negative pi over 4. So we now have to start thinking about our signs. Now, when we are in quadrant 1, right here, this is quadrant 1. Hopefully you remember from your trig class in high school. This is quadrant 2. This is quadrant 3. And finally, this is quadrant 4. Now, why am I bringing that up? Because in quadrant 1, my x and y points are both going to be positive. I have to have a positive, positive to be in a first quadrant. I go over positive and up positive. However, when I go to quadrant 2, I have to go over negative, and then my y value will go up positive to be in quadrant 2. Go ahead and put parentheses around the quadrant 1s as well. Quadrant 3, I will have to go over negative and down negative. So now I have negative, comma, negative values in quadrant 3. And then quadrant 4, I am still going to go over a positive value. However, I go down to a negative value for my y. So my y value would now be negative. So instead of the square root of 2 over 2 and the square root of 2 over 2, my y value is going to be negative square root of 2 over 2 because it has to be to go down here below the y-axis or below the x-axis. Now look at 3 pi over 4 and the terminal point determined by pi over 4. Here I have my pi over 4, and then here if I travel 3 pi over 4, I will end up here. Now, keep in mind that this is a second quadrant where my value is negative on the x and positive on the y. So instead of the square root of 2 over 2, square root of 2 over 2, it's going to be negative square root of 2 over 2 and positive square root of 2 over 2. So hopefully you're getting the idea that if you get the common values that we are studying in the first quadrant, you can figure out what those values are in quadrant 2, 3, and 4 by thinking about the signs. Now let's take a look at negative 5 pi over 6. Negative 5 pi over 6, I would start here and I would go around to here. Okay, now pi over 6 would give me the terminal point of the square root of 3 over 2 and 1/2. And again, how do I know that? You have to study it. You have to study it to know it. And since that's the case, if I think about going 5 pi over 6 backwards or clockwise, then I'm going to have a negative value of what was positive. So it's now negative 3 square root of 3 over 2 and negative 1/2. Now let's take a look at reference numbers. So from examples 3 and 4, we see to find a terminal point in any quadrant, we need to know the corresponding terminal point in the first quadrant. Like I said, you need to know your first quadrant really well. And once you do that, you can use those values in the first quadrant to get your values in the other quadrants. So when we know that, we say let T be a reference number, and the reference number T bar associated with T is the shortest distance along the unit circle between that terminal point determined by T and the x-axis. So figure 8 shows what the reference number T bar is to know the quadrant in which a terminal point lies. Here, if I have T equals my T bar, I also have to remember that if I come around this far, that this is also the same distance going this way as right here. Also, from here to here, the same distance as it was in quadrant 1, and from here to here, the same distance as it was in quadrant 1. It's just On the second one, I'm in quadrant 2. Now I'm in quadrant 3, and then I'm in quadrant 4. So these reference numbers are all T. If the terminal point lies in quadrant 1 or 4, where X is positive, we can find that T-bar by moving along the circle on the positive axis. However, if it lies in quadrant 2 or 3, where X is negative, we find T-bar by moving along the circle in the negative, to the negative X-axis. Find the reference number for each value of T. Let's take a look at these examples. Here I have 5 pi over 6. So again, once I get here, what is the shortest distance to the x-axis? Let me find a different color here. Let's use purple. Okay, so that shortest distance would be right here. In the second one, I have 7 pi over 4. So again, the shortest distance would be right here from the x-axis again. From the x-axis and 2 pi over 3, my shortest distance would be right here to the x-axis. And then finally, when I have 5.80, my shortest distance would be 0.48. So in order to find this, you could have T-bar equal pi minus 5 pi over 6, which would give us just pi over 6. If I have 2 pi minus 7 pi over 4, I will get pi over 4. If I have pi minus 2 pi over 3, I will get pi over 3. And keep in mind with all of these, I'm thinking about the shortest distance from the x-axis. And the x-axis lies on either pi or 2 pi. So you're going to be using either pi or 2 pi for one of these, whichever quadrant that it's in. If it is in the second quadrant, or if it's in the third quadrant, you're going to use pi, because that's what it's closest to. Remember, if I have my axes here and I'm coming around either to the second or I'm coming around to the third quadrant, then this is the part of my axes that I'm going to be looking at, which is pi. However, if I have 7 pi over 4, let's take a look at that. I'm going to come all the way around to here. So in this case, I'm going to be looking at my 2 pi axes. Now we call this 0 and we call it 2 pi. So I'm going to be looking at the area right here. Okay, so that's how I will use that. And then again, my 2 pi over 3 is also in there. So either I'm going to be, well, I shouldn't skip over this fact. If I'm in the first quadrant, coming up here, again, my closest x is going to be my 2 pi y-axis right here. This is 0 or it's 2 pi. And this up here is pi. So hopefully that makes a little sense. Okay, so 5.80 is over in this area, so it's going to be using the 2 pi axis. using reference numbers to find terminal points. So to find a terminal point P determined by a new value, we use the following steps. First, we're going to find the reference number of T bar, and then the terminal point Q, A, comma, B, determined by T bar. The terminal point determined by T is going to be plus or minus A and plus or minus B, where the signs are chosen according to the quadrant in which the terminal point lies. Find the terminal point determined by each given real number. Let's take a look. Again, we have our reference numbers associated with these values that we found in example 5. So here we have a square root of 3 over 2 and 1/2 right here. And that would be at pi over 6. And again, these are all of the values that you should know. And once you know these values that are in quadrant 1, you're also going to have to take a close look at these values that are in quadrant 2, 3, and 4 that correspond to these numbers. Since the terminal point is determined by T that is in quadrant 2, the x-coordinate is negative and the y-coordinate is positive. Again, I'm going to repeat that because if it is in quadrant 2, which is this area right here, your x-coordinate is going to be negative and your y-coordinate is going to be positive. So the desired point would be negative square root of 3 over 2 and 1/2. Now for the second one, it's pi over 4, which is in the first quadrant, so that's square root of 2 over 2 and square root of 2 over 2. But since the terminal point for that number in quadrant 4, it will be the x-coordinate of positive value and the y-coordinate of a negative value. And again, that's because it falls in quadrant 4. Okay, and this is down here. I shouldn't confuse it with what's right above there. Okay. All right, let's look at the desired terminal point. There we go. Now we're going x positive, y negative. And C, the reference number is pi over 3, which determines the terminal point 1/2 square root of 3 over 2. This point is in quadrant 3. Since it is in quadrant 3, we're going to have a negative value for the x and a negative value for the y. So the circumference of the unit circle, of course, is 2 pi. The terminal point determined by t is the same as determined by t plus 2 pi or t minus 2 pi. So in general, we can add or subtract 2 pi as many times as we want without changing the terminal point determined by t. And we're going to look at an example where that rotation happens for more than 2 pi, and we can simplify it that way. So now I have 29 pi over 6. So this is kind of crazy. So what you want to ask yourself is how many 2 pi's are in here? Well, if I take a look at this and I want to subtract 2 pi each time, and I make that 2 pi as in over 12, I'm looking at subtracting 12 pi over 6 as many times as I can to rotate all the way around? Well, you can see you can do it once, and then you can see you can do it a second time. And after I do it a second time, subtract 12 pi over 6. How am I getting 12 pi over 6? Because that's 2 pi. I will have a remainder of 5 pi over 6. And if I have a remainder of 5 pi over 6, and, you know, of course, they're adding the 2 pi and 2 pi to be 4 pi right here. So now we need to subtract that 4 pi away from it, and we're just left with 5 pi over 6. And we're going to go from here around to 5 pi over 6. We know we are in the second quadrant, so our x value is negative and our y value is positive. And that will be it for this section. It's a pretty long section, 31-minute video, so hopefully you can go back and revisit. And of course, if you have any questions, we can answer those on Tuesday.